So let's look at a real problem here. We want to, where is the eraser? All right, ignore this part. We want to solve a value of y hat at this point, it regenerates values of y which are very close to my observation. All right, which means I can define my loss function to be. Can you see this? All right, so I can I define my loss function to be y hat minus y squared. Right? What does it mean? That means I'm taking the value of my observation and I make a prediction here at that value of x, and I subtract them, square them, and I say I want this difference to be minimum. So this is a positive number, right? This is a positive number. I want to minimize it, which means I want to get it as close to 0 as possible, which means I want my line to be falling on top of that line, right? All right. Now, what is a good approximation? How do we characterize a line? We say y hat equals w times x. So x is here. W is the weight function that we have to compute. I think I'm putting some people to sleep. All right. But it will get better. Wait. So what do we do? The loss function, I will rewrite my y hat as w times x. And this is minus y. And I square it. So I take this loss. I take the derivative with respect to w. That's this part. And I pick a learning rate that we will talk about. And then I start taking steps. So I start evolving the weight. I start with a random weight, and I start evolving it. So let's say I start with w equals 1, and alpha is 0.1, for example. So at w equals 1, I make a prediction. So this will be x times 1. That will be x minus y. And y, at this point, I have the value here. And I compute the derivative of that, and then multiply by the learning rate. And I update my value of w. So when w is new, that means my predictive function is new. And then I compare the new value to my observed values. And I say, how far away am I from that? And I keep doing it until the loss is minimized. So what is the derivative of loss with respect to W? You have to go back to your, when did you learn derivative? Kindergarten? So we have to go all the way back to that time. And actually, I have a better way of showing you that. What happened? Google. Do you see it? Mm-hmm. All right. So, and we are getting to our hands-on time because you're going to do all of it yourself, the fun part. So, what is the loss? We don't have an eraser here? Oh, thank you. All right, so we have, let's compute the derivative of the loss, right? Who wants to do it? Let me make it easier. This is Wx minus y squared divided by W. So let me see. Natasha, you want to do it? So we want to take the derivative of this with respect to W, and so explain and do it.
So this is a composite function.
Can you hear her? No. Wait. I'll keep this for you.
So I can hold it.
All right.
Yeah. How deep should I go?
Can you hear her?
Hello. Yeah.
Is it good? Mm-hmm. All right.
So we first make the derivative of this function square. This is twice whatever is inside the argument times the derivative of the argument with respect to W, which
So
is
maybe do it step by step. Do the chain rule and break it into.
So do I do the W like that?
Yes. Yeah. So everyone knows what happened here. Yes. Good.
Do you mind writing the video? Is this slide?
Sure. So now we have twice. And what's the derivative of this with respect to W? So the first thing we have x, and the derivative of a constant with respect to W is equal to 0. So this whole thing is x, right? So now we like
Great. All right. So, thank you. Thanks. All right. So you see, this is how the networks actually learn, and this is much simpler than what you might have thought about when you build the AI, and then you train it. This is what is under the hood. All right? And so let's, oh, something happened. All right. So let's take this 2x times wx minus y. That is d lost by dw, right? And then we multiply it by the learning rate, and we subtract it from our parameter, and we update our parameter that way, and then we keep doing that. All right, where we get to the minimum, this becomes 0, and we are not moving anymore, and we are done. All right, so how do we know? We actually take enough steps for now, for what we are doing here. We take enough steps that we will be sure that this will have converged. All right. Google doesn't like us today. This is what we are going to do in a few minutes in the hands-on session. We will start with generating some simulated data. The data is x times 2. All right, so my actual y is 2 times x. And so 3 values only. This is big data. Work with small numbers, and then I will pick a random value for my weight, so I'll set it to 1, and I define my function. This is defined as forward. Forward is actually the name of my predictive function, which is x times w. All right, and my loss function is forward x, and so my predicted value of the function is forward at point x, and then the loss is predicted y minus actual y squared. Easy, right? And then we compute the gradient as much as you just did. Here it is 2 times xw minus y. Right? So that's the setup of the problem. And then we start training. We will take 100 steps. And for every step, we pick the x value, and then we compute the gradient of the loss function at that value of x. And we pick the learning rate to be 0.01, so 1%, multiplied by the gradient, subtracted from the current value of the parameter, and then compute the loss, and then do it 100 times, and then we look at where we are after taking 100 times. All right, so. And it prints the values for us, and we'll see that the loss function actually goes to small numbers, and we look at what comes out of that, and let's actually do it. What happened? Do you see this? Is it big enough? Very big?
Too big, actually.
All right.
Yeah,
Is this good?
Yeah, this is good.
All right. So when we go into the hands-on part, I want you to start from the beginning. You can do control return on everything, and it runs, but don't do that. challenge yourself, read every line, make sure that you're comfortable with every line, because we are going to build on top of that, and it will get complicated, a bit more complicated very soon. So make sure that you are comfortable with every line of what we have here, and you basically are going to do what we just saw there. And then after that, and then we have a little visualization here. So this is what happens. We start with a random line, and then we start learning the weights to fit it there, and after 100 steps this happens. So this is a good visualization of how how the system is learning the line. All right? So we are going into the hands-on session, and then we will talk more about it. I think 15 minutes should be more than enough. So take 15 minutes, do this, and then take a couple minutes off, and then we'll come back to talk about how to do it in PyTorch.
Willie has a question.
Yes.
The link to the notebook are in the student's important link file. He said you need to let us know which one to start with, backprop or gradient descent.
Gradient descent,
Gradient
as you
descent.
see here.
Okay.
So start with gradient descent. Don't look at the backprop. You don't know what backprop is yet. And we had a question there.
Yeah, I think someone should have reminded you that how to not miss the global minimum.
Yes, thank you. Let's do the hands-on, and then when you see that, we will come back to that. Thank you for reminding me. Snooze. Remind me again in 10 minutes.